walk over here. Yes. Hello, I don't know where this camera's pointing because I can't see the screen. My name is Curtis. Thank you for joining us here at the New Orleans Game Dev Meetup. We're joined by a live studio audience today. You're here with us in the month of June. Can you press the button that says display with camera? And then click the presentation on the right mirror. Nothing works already. No. So this is the month of June. Yeah, there we go. And you're here with the Game Dev Meetup. I'm Curtis, the President Meetup host here for NOGD. Who is NOGD? Well, we're a nonprofit, registered 501c3. We provide community for game developers. We host meetups like this one right here, right now that's happening. We have game jams, small hackathons where you make a video game in a small amount of time. We've got classes at the New Orleans Public Library. We give hardware donations to fledgling game dev startups in need, and we do a lot more. We also have a Discord. You can scan this handy dandy QR code here, and you'll get an invite to our exclusive Discord where all the great things happen, like conversations about trains and stuff. That happens a lot. Yeah, it's a great place to meet other people who are game developers, especially local ones, find out about things that are going on in the community and in the city in general. And it's just chill, we like to hang out, we have a good time, it's fun. And that brings us to our presentation by the wonderful Etienne Blanchet. There you go.
Hello.
Thank you.
Okay, thank you all for having me here. It's pretty great. I've been coming here for a bit, saw some pretty great presentations. So I want to do a presentation of my own to give back. So it's called A Non-Level Designer's Guide to Level Design. So as you might notice by the title, I'm not a level designer. I do a lot of game design, and I've done some level design, but it's not my focus. So I wanted to focus on, well, what about those of us who haven't professionally or educationally studied level design? How do we build our toolkit? And that's what this is going to focus on. Level design is like a broad spectrum of trying to just get better at it. Can you click in the presentation, I think? No worries. So to give a little bit of background about why I might have some interesting insights about this topic, as we can see, I got my programming degree at Northwestern State University, and I'm working my MBA at LSU. So no education based in level design. So coming in very fresh, very great eyes to see it. But I always wanted to do video games. And can you click in the presentation again?
1 second.
No worries. So I shall entertain you all. Let's see, programming MBA. Programming at LSU, NSU. Pretty bad, gonna be honest with you. Don't recommend. MBA at LSU, pretty great. You barely sign in, and they just give it to you basically for free at this point. So over here, I was like, oh, I want to work on games myself. So I created my own studio, Intron Digital. My position there, we'll see. I hope we make any money. We're probably going to lose money on every game. But maybe one day that will say president of successful company. So more about me. While I'm working on my game for the startup company, the startup studio, I've been trying out a lot of level design. We got here some paper prototyping I tried for a level, brought that out to an NOGD meetup to test it out, went very well. Then we took that prototype, we started making some gray boxing to test it out in engine. So this is it very early on. And then that eventually got transitioned to, wow, some placeholder sprite work and some sprite work's getting there. So fantastic, so wonderful, we're getting there. And you too can do that if you follow this presentation, maybe. Okay, so great sources. A lot of my learning from this has come from these 3 sources. The first one is like a cornerstone book of the industry. It is an architectural approach to level design. Literally, you look up what is a good level design book. That's the first one that pops up, and it deserves to be recommended. It's awesome. It's fantastic. It's amazing. Up next, this one's a little bit less recommended, but I personally really appreciate this one, Level Design for Games. You get a lot of very in detail examples that show off some pretty cool ideas you might come up with level design. However, on the other hand, it also focuses on dead game engines, so some fluff in there that you can just literally skip over. And this one's awesome. It's Level Design Book, but that's a lie. It's not a book. It's a website. It's online, and it's got a lot of great little sections that can tell you different parts about level design. And the best part is it's open source, so you can go ahead and you can check it out. And you are.
Blood Gulch?
I'm gonna say yes, but I don't know.
It is.
Yes,
Yeah.
that is Blood Gulch.
I would
So,
Blood Gulch.
yeah.
Any day of the week.
Absolutely. That's an example of good level design. You can notice it from right here. So go check out this resource. Okay, now, as we were talking about my ability to give this presentation, we got the Dunning-Kruger effect. You have no knowledge, you think you're awesome. You gain some knowledge, you realize you're not hot shit, and then you get better as you get over here. I'd like to imagine all my research, all my practice, I'm somewhere around here, slightly below average. A lot of book theory stuff, not enough practice. But, I think that I can give a lot of good stuff about this presentation. Take what I say with a grain of salt, of course. So, level design, what is it? Well, it's not game design. Game design is a much bigger field, has gameplay, narrative, levels, etc. Or a level designer is like a subset of it, I would say. But it's all other stuff than that. It's more specialized. Can you click in the presentation again?
It should be in there.
Oh, sorry, it just wasn't working. Okay, then we got UX. This is a specialized field. Within that would be focusing on things like UI, user experience, stuff like that. That's not level design, obviously. Then we get to another example of a specialized field that's also not level design, systems design. Like you got ice, fire, how does it affect the world? That's a systems designer, not a level designer. Level designer, very specifically, it focuses on the level. How is it positioned? How is its composition? It starts implementing little bits and pieces of it to test it out. And then as you get further along, it starts putting props and stuff like that to see how it works and starts iterating it on trying stuff out like that. It focuses on the level itself, not the mechanics or the systems, not the user experience in the system with UI and stuff. But it does have some overlap with those.
Neon White. I don't know the other games.
That could be true. You know more of these games than I do.
Neon White's the comic book.
Oh, nice. Yeah?
Oh, that's I think that's a Sherlock Holmes game.
Might be. That would make sense. Huh?
Just for Chopped Monkey Oscar.
So, level design has a problem with big L and little l, a lot like liberalism. You have big L, level design. That's stuff like your layouts and your blockouts. Very specific. You're not focusing on things like visuals and aesthetics. But then you got little L level design. That includes your visual stuff like your lighting, your texturing, your modeling, your concept art. This presentation is mainly going to be focusing on big L level design. So composition, that sort of stuff, how the player moves through the environment. It might be. Actually, it almost certainly is. So, level design, we need goals. If we don't, this happens. You get a bunch of gunk. So what are our goals for level design? There can be a lot of them, but there are three that were mainly brought up. Number one is adjusting your player's behavior, okay? As people are going through your level, they start off with a base amount of knowledge coming into your game, but as it goes on, you want them to gain knowledge. So for example, start off with Super Meat Boy. Watch this guy, he's playing this level. He has no idea what he's doing. He just needs to jump up there. He can't figure it out. Look, he's still going. But now, we've seen him there. He's struggling with such an easy thing as jumping. By the end of the game, this is the same guy. Check this out. He's going around all those saw blades. He's jumping up. He's doing all these crazy stuff. That's what happens with good level design. Your player gets better. They learn. So adjusting your player's behavior. Number two, transmitting meaning. We've all played, or we've seen, hopefully, this very famous scene from Super Metroid. You start off, it's nice, it's calm, but it's very mysterious, it's very creepy. And then you go further, you find out you're being invaded, and hold up, it's coming. Can someone click in the presentation again?
I'll give it a click-clack.
Okay, boom, now the level design shift. You've got stuff falling from the ceilings. This once peaceful place now is shooting off hot puffs of air that can hurt you and knock you off course. The screen is shifting. That's more visual, but it brings up the idea that the mood of the level, the way it works, by introducing elements into a previously existing place, you can transmit meaning of how you should feel into the level. I think the word is like ludonarrative or something like that, using big words, yes. So, yes. Well, this is the exact opposite. This is an example of ludonarrative completeness, I guess. Euphoria, yes. Resonance. Because we can see that you're in an exploding ship, and level design shifts to reflect that. And then kind of going along with the idea of imparting meaning into the space with level design itself, we have augmenting the space, putting information into the space that helps the player play the game. Obvious, super on the nose example is Portal. You walk into a chamber, you've got little icons. What are you going to expect in this portal? Literally, the level design puts that in there for you to see what's up. A little bit less obvious, in Mega Man, when you're going to a boss stage, every boss stage has this little room right here. And that's a subtle cue like, hey, stock up on your stuff, change your weapon. And then you know you got the boss snacks. A very subtle way where level design can augment the space and impart knowledge of how to play. Not just narratively, but also with how to do the gameplay. So those are our 3 goals. Now we're going to fill up this toolkit. There's a lot of different tools. You should look into your genre, and you should find out the tools that are in that genre. And there are too many to cover today. So we're going to cover a couple of really common ones that might be helpful regardless of what you do. So number 1, skill gates. That's right. It is a skill issue, but the game is going to help you get through that skill issue. And we can see the most famous example, literally World 1-1. There's a Goomba there. You need to jump over him to pass. It's the first thing you see in the game. If you can't do this, you can't play the game. But you spam that controller enough, and then we see over here, he's trying. Oh, he's learning. Boom. He has learned how to jump. Pretty amazing stuff right there. That's good level design. You have taught a skill gate. And then a more advanced version of a skill gate, going back to Metroid. Over here, you got to jump up here. You've already learned how to jump, but now you got this weird thing. What is that? A morphing ball. What's that? Who knows? When eventually the little animation stops playing, you get this crazy looking eye. It's scary. It makes a loud noise. It makes you want to run away. You're running away, but you can't get up that hill. It's still making a noise. You go in this corner, the noise stops. You leave that corner, noise starts. So, oh, there's something in this corner. What do? Spam all the buttons. Keep spamming it. Eventually, boom, you're out. Good game design. So it forces you into a place where you have to figure out what buttons to press. And it doesn't tell you like, hey, these are the buttons you press. It lets you figure it out. It's called a skill gate. Very great skill to learn. Going on to the next one. Introducing mechanics in a safe area. So it would be pretty unfair if you're playing a game, like for example, going back to Super Meat Boy, and all of a sudden this sky falls down and kills you for absolutely no reason. Those are called like Kaizo games or stuff like that. Some people like them, a lot of people don't. So instead, we introduce mechanics in safe areas. An example of this is Portal. Once again, going back to this master class. They noticed that players would all the time run down, grab the portal, and they wouldn't know what to do. So they introduced this thing that they called a gate. You have to sit here and you have to watch this portal shoot portals in order to progress. The gate will not open if you do not look at it. And this is a good way of safely saying, hey, look at this. It's doing something. Learn that it's doing something. So that way when you go and you grab it, you actually know what you can do something with it. Then going on to the next one, this is me stealing an Ego Raptor bit. You got Mega Man. Again, you've got these guys. They throw stuff, and you don't want to get hit by it. So what do? They're pretty smart, these designers. They've got extra padding for where you move from when you first see them. You will see them throw a bow up before you first run into their range. You know how long they're going to shoot, you know when they're going to shoot, and you know what their projectile is going to look like. So just fantastic game design of a more subtle way where you're not putting a literal gate saying, hey, you will learn this mechanic, but it's like you basically got to wait. You got to see them attack before you can engage with them. Off from mechanics in safe areas, I want to introduce more of a philosophical, more, I guess I would say like less physical example, less concrete example, and more of a vague example if this makes sense. Let's suppose we have 2 games, okay? And you're going through these games and you're fighting a rebellion. There's this oppressive light, and it's forcing everyone to die very slowly. In one of them, you got this place, okay? It looks like this, and you're fighting the rebellion, and then you fight, and you win. And then the place looks like this. No difference whatsoever. Now, that might be an engaging story, but the level didn't change. It didn't reflect anything you did. Now let's go to another one. The exact same scenario. But instead, let's say you start off on this one. The sky is filled with light. There's a lot of crazy enemies here. The level design is a lot harsher. And you're fighting through and you're fighting through and you win, but now, boom. Now you go back to what it was in the first example, except this is after the level design was the other one. The level reacted to you. And this is really important. Reacting to the player is fun. People like seeing the mystery, the intrigue of, oh, what's going to happen next? And I could try explaining this, but I think that one of the best people who can explain this is Gabe Newell. So I'm going to let him go ahead and explain this. All right, no worries. So what he's going to be
the game recognizes at that point in time, that was a useful way of making design decisions. The point where you'd be sitting in a design review and somebody say, that's not realistic. And you're like,
all right, so Gabe Newell is going to talk a lot about what Valve came up with as their theory of fun, and that was that the world reacting to you is fun. He's going to go through a couple examples from some games they produced, like Half-Life, etc. And I just want you to focus on what he's talking with about how reacting is fun. Okay, you can go ahead and play it.
where you'd be sitting in a design review and somebody say, that's not realistic. And you're like, okay, what does that have to, like, explain to me why that's interesting, because in the real world, I have to write up lists of stuff I have to go to the grocery store to buy. And I've never thought to myself that realism is fun. I go play games to have fun. And so we had to come up with some notion of what fun was. We knew it was an ad hoc definition, and it was the degrees to which the game recognizes and responded to the player's choices and actions, right? You know, in behavioral science, you would say we're explicitly talking about what were reinforcers and what the reinforcement schedules were, right? At that point in time, that was a useful way of making design decisions. The point I would make is, if I go up to a wall and shoot it, to me, it feels like the wall is ignoring me. I'm getting a narcissistic injury when the world is ignoring me. So does this, like, to me, I was trying to convey to the user a sense of, yes, you were making choices, yes, you were progressing, which meant the game had to acknowledge that back to you. If you shoot at a wall, there have to be decals. If you kill a bunch of Marines, the Marines have to run away from you, right? You have to have this sense of the game acknowledging and responding to the choices and actions and progressions that you've made. Otherwise, it loses any sort of impact.
Yeah, so very eloquently put, given a lot of examples. And going back to the previous one, we can see that you should design your levels in such a way that they do react to the player. So you've got these couple different tools. You've got skill gates. You've got introducing mechanics safely. You've got stuff like having the level react to the player. Now you want to go and you want to write your, can you tap into the presentation again? Okay, you want to write your ideas down. So you got your paper out and you still got your paper out and you're thinking, what do you want to do? And you got your paper out still again, nothing's coming. And the reason for that is just because you have the tools doesn't mean like you're very comfortable or fluent with them. So what you can do is you need to learn how to use that toolkit. Develop your level design sense. So, you know, all presentations like these, they need their acronyms, you know, so I didn't want to leave out of that. So I came up with what I think is a pretty clever acronym. You need to practice. Wow, I know, I didn't stretch to make that one work at all, but practice. You gotta prepare, research, atomize, connect, test, iterate, communicate, and experiment. There's more you can do, but this is a pretty good starting point for level design. So what do we mean when we say prepare? Well, there are a lot of different things you gotta know about your game. This is where you get to the nitty-gritty of what your game is. A level is not made in a vacuum. It's made in the context of a larger work. So your player movement, your player knowledge, what is it gonna be at this point in the game? What are their skills? Can they run? Can they jump? Can they shoot? And then drilling in more specifically, what's their movement speed? How long does it take them to move X number of units? What's their max jump distance? If you've played any games, you've probably seen these, and especially if you played Valve games, You've seen these textures. These tell you the standard heights of various things. And they tell you things like doors, walls, and all this stuff. If you can get these measurements very early on, you won't have to redesign your levels later when you realize everything's out of proportion and everything's out of whack. Because you've got standardized units. You can see on this floor, like, hey, how far is he going to jump? 1 unit. If he's long jumping, maybe it's 2 units. You've got to get all this stuff in early so you don't have to keep reworking your work. Up next, you got things like mechanics and game aspects. This is the actual physical what's what of your game. Not stuff like jumping and running and shooting, but more stuff like your camera. So if we go and we check out, going back to Metroid, we got Metroid 2 on the Game Boy, and we got Super Metroid. What the camera can see on these two things is very different. You might be able to make a very vast, expansive area on Super Metroid, but you can't see all that on Metroid 2. You design two very different levels based off of the constraints of the game. So knowing the actual mechanics, like the physical mechanics of your game, is super important to get down on paper early. And then up next, your narrative. Where's your place in the story? Are you at the front? Are you at the end? What's the goal? What's the mood? What's the vibe? Should you be depressed? Should you be scared? Should you be happy? These sorts of things are going to change your level design. For example, if you're in danger, maybe you have narrower areas. If you're happier, maybe you have broad areas where you can go a lot of different places. That's all going to change based off the mood. Up next, research. You're not the first person to have level design problems. A ton of people have come into them, and they put a ton of time into it. Don't waste your time reinventing the wheel. So for example, let's say you want to do a third-person platformer, right? How do you design levels for a 3D platformer? You could sit down and you could try over and over and over again, iterating on how you would make one, or you could look to people who worked on it in the past. Going back to Mario, look at this. Old one, you walk left to right. End of the game, you walk left to right. In 3D, this doesn't really work anymore. So they had to sit down, they had to figure out, how do you design a level in 3D? And if you notice, that's a level in 3D, that's another level in 3D, that's another level in 3D. When we look at all these levels, what do we notice is the thing that connects them all?
You're going up.
That's right, you're going up. Verticality. Go ahead and learn what people before you have learned and test it out and try it out. There's probably a good reason they did it, and they probably spent infinitely more time than any of us could ever spend on it. So, pretty good stuff. Learn from other people, research.
Yeah, the very start of the game, right? Your
Yeah, up
you go up that
Bob
little
Bomb's
winding
Battlefield.
path, like the very first thing you see is the Castle in the distance.
Yeah.
That's why whenever they make games with balloons, they can't resist actually making it flat. They always end up adding like hills and stuff like that.
Yeah. Yeah, verticality is the name of the game in 3D space. So, and not only that, but if we go back to verticality, the further on the game you can go, the danger increases with the amount of verticality. You can see here in the start, you've got a lot of safe area underneath you while you're doing it. And this is one of the last levels, Tick-Tock Clock. Not only is it literally just vertical, but there's nothing to save you at the bottom. That's a lot of how the danger is increased in 3D platformers. So these are things you can learn by researching what other people have done before you. Up next, now we're going to look at the actual nitty-gritty of how you put your level design ideas together with atomize. The level design book that we talked about, architectural design, level design, talks about using a molecular level design pattern. And this includes building a backbone out of nodes. These are the areas of gameplay where your gameplay is super unique and is where the core content is. So we can see here, we've got a great, fantastic horror game that was not overplayed at all, Slender in the 8 pages. Wow. See this thing right here? This thing's horrifying. The rest of the game, you're going through the woods. However, this is a massive building. It changes up the gameplay. What's going on in there? A lot of dead ends are going on in there. This is scary. This is like a node that you can build off the gameplay. When you think of the 8 pages from this game, it's built around nodes, where every page there's some unique interaction, either trucks that are blocking your paths or stuff like that, where you have an interesting set of gameplay. So in between those nodes, well, going back to nodes, you have different ways to set up nodes, and here's like a possible example. You could have node 1, introduce an item. Node 2 or node B, expand on what that item can do. Node Nice. 2 node Bs, we're trying to be special. Reinforce the item. Go back to like the first node A and try to get them to use it again. And once they're totally familiar with nodes, go to node B3 where you test the knowledge in a novel way. They've got use into this item, so try it out. And one of the great things about the node model or the molecular model is that all these nodes, you don't have to know how they connect. You just have to know the actual gameplay of it. So if you want to change it out, or if you try stuff out and it doesn't work, you can just take this node, take it out, slot in another node. And this was actually what was used a lot in Portal. When they would test the levels out, they would design them and they would find out that, oh, this one that we thought was harder, actually the players didn't understand it. And so instead of having to redesign the whole game, because when they were originally making it, when you go from area to area, it just teleports you. They could literally just take this node and take this node and flip them. So designing it like as a molecular node structure is very good instead of having to like redesign the level over and over and over again every time you make a little change. So how do you connect these things? We have edges and we have paths. Going back to Slender in the 8 pages, we got a forest and a forest. You walk through it. It's a way to get from one place to the other. You can see this little truck over here. This is where another page is, but you got to get through the forest to get there. So the edges and paths are the ways you get from node to node. Going into a little bit more example of how these things go together, we have Castlevania Symphony of the Night. This one just makes it super apparent. Look here. This is a pathway or an edge. This is a pathway or an edge, pathway or an edge. All these big rooms, bet you that's a node. That's definitely a node. That's a node. You can look at it and you can tell just by the visuals of it. But that doesn't mean that gameplay doesn't happen on edges. For example, this is an edge or a pathway, but you have to activate a skill to go through it. There's even an enemy encounter there. Going up further, this is a node. There's a lot of core content gameplay here. You gotta dodge this guy. You gotta go up this crazy set piece of the clocks and the gears all moving together. So this is an example of how you can have nodes created, and then you can link them all together with the pathways in a fantastic little manner. So we've got nodes, we've got edges. Now what else do we want to do to connect these things together? That's right, we want landmarks. Boom, Mario Odyssey, you're in the desert, you see that big pyramid, you know where you are in this desert. You look up to it, and you're like, oh, I'm north, I'm south, I'm east, I'm west. You can see it from anywhere. Going over here, we got the Citadel from Half-Life. Big thing, you can see where you are in the map. It helps you orient yourself with where you are in relation to the rest of the world. Fantastic name, I love it, called Weenies. That's because the idea of using landmarks in interactive spaces actually comes from all places. Walt Disney World, yes, putting their mark on everything. When the Imagineers were designing the Magic Kingdom, or more technically Magic Land, they were like, wow, it's kind of confusing going through all these places and putting everything in perspective. So like, what if we put something in the center of the park that helps anchor it? And you can look to the park and see, am I in the back? Am I in the front? And from there, know what land you're in. And they call that thing a weenie. So thank you, Walt Disney Imagineers, for giving us a great name. So you look here, boom, I'm in the front of the park. How do I know? I'm looking at the front of the castle. I'm in the back of the park. How do I know? I'm looking at the back of the castle. It's a fantastically easy way of noticing. And one of the best ways in games that I think have done this recently, and a really good example to use, is Elden Ring. Boom, the Erd Tree. It's big, it's massive. It tells you where your objective is. It's a giant glowing go here marker. And not only that, it tracks your progress throughout the game. You're getting closer to that tree, boom, the tree is bigger. It's a massive weenie pointing you in the direction to go. Now, of course, you can do this in smaller levels, as we saw with Mario Odyssey and its pyramid, but it's just a fantastic concept. Weenies. Okay, now, we've connected our world together. We've got something that's playable, where we want to test it out. And there are a lot of different ways you can test it out. First off, you can play it yourself. It's pretty good for very basic things, like, oh, does this level load? Did I put in a wrong string or something like that? But you're not going to be able to understand how like other people play it or things that you might glance over. So you can get a critique. This is from people who are also game designers. Pretty great for finding things that would be harder that your layperson wouldn't understand. Like, hey, this just doesn't feel right. Help me make it feel better. And then you got public playtesting, which is good for knowing how your average person would play the game. So how would you set up a playtest? Here's a very basic set of instructions. Number one, you're going to prepare. You're going to figure out what you want to test. You're going to put together what area of the game you want to test, and you're going to have it ready for them to play. You're going to develop some instructions like, hey, here's the buttons you press to move. Here's this sort of stuff. And then you're going to figure out what sort of data you need to collect. And this can include things like going ahead and buying a stopwatch or some way to count the time. After that, you're going to brief the playtester. Tell them, hey, this is the basics of the game. This is how you play it. And then you're going to show them the instructions. You want to keep this point pretty brief. And then you're going to go ahead and you're going to observe them. Just watch them. You don't have to interrupt them, interact with them. Let them go and let them experience the game. Track whatever stats you wanted to track, like, for example, playtime, deaths, or wins. And then optionally, it's pretty awesome to have stuff like heat maps. So if that's something you want to collect, think about that before you give them the game. After you do that, you're going to want to debrief the play tester. This is after they finish playing. Ask them some questions. Hey, how was it? What was your favorite part? What did you like about it? What didn't you like about it? What did you think of this mechanic? And this is a super big one. Remember, be kind and thankful. They're taking time of their day to help you. Say thanks. And then, so you thank them, you got your data. Now what do you do with it? You analyze it. Figure out what you can do with it, what you went wrong, what went well, what you can iterate on. Speaking of iterating, no worries. Iterating, wow, what a lead in. So we have a lot of different ways you can iterate, and there's no one right way. So here's an example of how you might iterate. We have this area where you come in, and there's a block up here. You need to push the block to open up this switch. And you got little hooks. You can jump between hook to hook to hook, and you go in and you push it in. No one figures this out. Why don't they figure it out? Well, while watching them, you notice they look up, but they don't see anything here because it's on the other side from when they walk in. So they just walk in, they walk out. How do you fix that? Well, maybe after watching them play, you iterate on it, and you're like, well, let's move it down, and let's move it to the other side of the room. So now they walk in, they look up, boom, there's the thing. But still, you got some players who just don't want to look up. Believe it or not, a lot of players don't like looking up. And if you went and you did your research correctly, you have an example like in Portal where they kept trying to get people to look up because there was a ladder you could climb up to get to, but they just wouldn't look up. And what they eventually found through iterating was that if you added debris falling from the ladder and then sounds coming from the ladder, that would force them to look up. So that's something you can find out by iterating, just trying again and again and again until more and more players figure out how to actually beat it. And now we go from this example at the start where most players, even if they don't look up, and even if they do look up, they see nothing, to this one where players look up who do look up can see this. And then now we're forcing the player to look up, and there's something that they would instantly look up at. So that's a great way of iterating. This is more of a macro level of iterating with game design from Mass Effect 2. This is how they did their iterative game design. Number one, they would have a narrative overview, and they would try to figure out what's the stuff with the narrative, the character design, 2D, yada, yada, yada. Not interesting for us. Next, they do the narrative gameplay, or the narrative playable. This is where they block it out. They figure out like what should go where. But there would be nothing like scripted here. There would be no play features here. It's just how do you move through the environment. Once they got that through, they would iterate on the same exact area, but now they would white box it. They would start doing some very basic, very crude dialogue, very basic interactions. And once they start seeing, can you see the fun? If you can see the fun, then it's time to iterate on the same space again, orange box it. Now you start adding more gameplay features to the area. You start adding some more actual physical props to the area. And if you get to is it fun, you can move out of here onto hardening. Can this be shipped? This is where basically you're at a playable game. It's not the best, but it's fun, it's playable. But you want to do one last iteration through it. You want to do finaling. This is where now your game isn't just fun, it isn't just playable, but it's awesome. Add a lot of effects, add a lot of really cool stuff here. So this is a more overall version of what a level might go through iteratively throughout its life cycle, whereas the previous one was more of a single node example of iteration. Next up, where to see, communicate. Wow, you're a person. People are smart. But you know what's better than one person? Two people. Get ready for this. Three people. That's right, even better. And level designers, we need to talk with other people. We need to figure out what they think. You might come up with cool ideas, or they might see something that they might want to point out to you. How do you do this? Well, there's a lot of different ways. Number one, we go to your local community, which you might just notice we just happen to be. Wow, New Orleans game developers, we've got a Discord. Check out this link. Go to it. Pretty cool, pretty great. You can notice a lot of events here, like, for example, show and tell. This level design prototype that I talked about, here's me showing it off, and here's me actually learning about how to design the level better because I'm testing it out with real live people. Yes. And then there's you over here at the studio session. We actually have like little teaching moments here where we can teach for about an hour, maybe a little more, and we'll show you how to do stuff. And you can bring your prototype there and you can ask questions. Or if you want to teach, you can teach what your prototype's about. Hint, hint, come teach. So, experiment. When I started off with this, I didn't really know anything about game design, but the way I got better at it was just trying over and over and over again, trial and error. As the acronym is, it's practice. You need practice. So here was an example of a paper prototype I did. This wasn't the first one I did, and it's definitely not going to be the last one I did. But experimenting with it and trying out other different methods is really awesome, and it helps you with your level design skills. We've got this video over here that's a level designer for CSGO. And he goes through a couple different iterative approaches he does with experimenting different processes of how he designed levels. So for example, I don't know if I feel like going through this because this clicker's not going to help me with it. But basically, what it goes through is he's got 3 different styles. This one, he works from the inside out. This one, he works from the outside in. And this one, he actually blocks out the whole area from the start, and he starts adding details at certain places. So these are all different experimental ways you can do with a level design prototype or a level design workflow. I outlined one here. There are plenty more. Go experiment with them. It's pretty awesome. Oh, video starting, but I don't feel like watching that right now. And you don't feel like watching that right now. So you can go watch it later. So we're reviewing. We're done. Congrats. Give yourself a pat on the back. We're going to take a bit of a break here, and we're just going to review. We have goals as level designers. We want to adjust player behavior. Look how awesome this guy is. We want our players to be like that, and they don't start out the womb playing that awesome. You got to get them there. You got to teach them. Next, transmit meaning. How does our level design help with the ludonarrative story going on? That's right. Big word, returned. And then finally, we're augmenting the space. How can we put information about how to play in the space itself? Up next, we have tools. Here's just a sampling of 3. There are hundreds, thousands of tools. Skill gates. You force the player to learn a skill at a certain point. Demonstrating mechanics. How do you show them a mechanic without them just being stupid and grabbing it and having no idea what's going on? And reacting to the player. How does the world change according to what the player does? These are awesome ways to make a level more impactful, more engaging, more fun. And then, of course, we got practice. That's what you need to do. You need to prepare. You need to research. You need to atomize. You need to connect. You need to test. You need to iterate. And you need to communicate. And, of course, as always, you need to experiment. Wow. That's it. That's all the slide has. Congratulations. We've reached the end. Here's my Twitter account. I might post this up there. I might not. I'll figure it out later. So thank y'all very much. Any questions?
You know, okay. I've always wanted to do more level design stuff. And really the last game. Yeah, look at us.
Yeah.
Oh, that's so natural. I didn't know they did that. The last game that I feel like, or I guess the last series of games that I feel like really invite you to play with their level design is it's like Halo, right? They have the whole like wonderful Forge suite.
Yeah.
Do you think there's a good like beginner's platform?
Well, I mean, it's going to depend on the level design you want to do. For example, if you want to do RPGs, RPG Maker is literally in the name. If you want to do like platformers, I mean, literally, if you're just getting started, you could do Mario Maker as a 2D.
Yeah.
But then there's things like the Steam Workshop. So there's a game called like Hat in Time, and it's got a workshop, so that's pretty cool. It just depends on the game you want to genre you want to play. So
So Hat in Time Workshop. Huh. Of course it would.
Yeah.
That's really cool that they do that too. I guess it has such longevity. It's so cool.
yeah, and it's got a lot of guides around that you can work with, so you're not just going in blind. So yeah, just look at the genre you like, and then look at hopefully the game has a workshop or something like that. Yeah. Any other questions?
Okay. So sometimes, I guess, yeah. Well, you kind of touched on it, but obviously, yeah, you want to introduce things to verticality, and you want to like be able to test levels at a gray boxing stage at the same time, though, right?
Yeah.
Is it ever sort of is there ever sort of a confrontation between like using a gray box to hit the basics, but needing the sort of finesse and fine touches of like lighting and visual effects and sound to kind of really complete the package and like achieve the goals needed?
Yeah, so that's actually something that with the different types of tests, you know, you got your public play tests and you've got your critique play tests with other game developers. And public play tests, they kind of do need those sounds and stuff like that, but you might not have them because the sounds and lighting and all that stuff is going to be way later into the level design process. So you can gray box it, but yeah, that's going to be a problem for public testing. So you might want more critique testing with other game designers who they're used to working in a gray box. They kind of understand it. But yeah, that is definitely a problem.
Yeah. Outside of that, I've always wanted to like. Do you use like certain asset store stuff for like? I guess you don't use Unity. You use.
I know I use Unity.
Do you? I mean, when you started making Graybox stuff, are you just using asset stuff or like?
So when I gray box, I literally go into Photoshop and I do a 1x5, and then I have a white, a gray, a lightly lighter gray, and then all the way to black. And then I just put that as a, I put that as a, what you call it, a as a tile map, and I just paint that because I only do 2D games right now. So literally all you need is a color. So, but for like larger games, yeah, absolutely use asset store stuff. Just remember to remove it later.
Pro Builder, I mean, it's good. I have a couple of students right now, and they, of course, like the very first thing before they do anything at their games, they want to make levels.
Oh,
right?
here's a good one. It's Open Game Assets or something like that. They have a ton of free stuff on there. Let's see, what else do you have that's free?
I mean, if it's enough free,
Yeah.
even though it could cost a little bit.
Yeah.
All right, yeah, because they're so gun ho on doing level design before they do any other mechanical design, which is I
Yeah.
think a little bit of a mistake. You
Yeah,
probably
yeah.
want your key mechanics in there.
So I mean, that's the like terrain of their stuff is very fun and easy way to get people
Yeah.
touching Unity.
Yeah.
You know, messing with the terrain, building that.
Oh,
Yeah, if you just like pull it up in a parabola.
yeah. You know something that I thought of? If you're trying to do like really, really basic stuff for children, right? Minecraft is probably a great like level designer.
Oh, totally.
Because it's very simple and literally everything's already there, and they're probably already used to using it. So unlike, for example, like Blender or something like that, you don't have to teach them like a new engine or something to use.
It's a good way to introduce them to nodes in a different way. Like
Yeah.
you can see sort of design repetition or
Yeah.
pattern repetition in the way that Minecraft like makes its well mines and stuff like that.
Yeah.
I've seen a lot of like college focused programming courses that teach them through like making Minecraft fun.
Yeah.
That's cool. Minecraft's cool.
Some people do like Roblox stuff.
Yeah.
Oh, we got a question in the chat.
Yes.
How much time should you put into a node before you give it a thumbs up or thumbs down?
As much time as you need, depending on the process. Is it fun? Does it accomplish your goals? Like, if like a node could be a boss fight, right? And if it's a boss fight, you know, you might be spending a lot of time. On the other hand, a node might be in Super Metroid. If you go back to the example where all the scientists are dead or whatnot, that's technically a node. But like, there's no movement there, or it's very minimal. I don't think that's in there. But it's going to depend on whatever your node, like the focus, the goal of the node is. Yeah, I don't think I have the dead scientists in here. Yeah, sadly not. Or like example, this is a node, right? The amount of time it would take to build this node out is going to be different than the amount of time it takes to build out the node that's the final boss, right? Like it's going to change depending on what the node is, the goals are.
And it's also interesting just to sort of the tile-based light work that makes things super obvious how far a jump is. Or
Yeah.
like what you're
Yeah.
tiny little nodes, but there's so much diversity within it that it's not obvious to a striking degree, right?
Yeah.
Smart grid.
Any other questions, or was that all right answer?
In reaching the goal, should you abandon it, retool it, or hold it for later? Maybe a combination of the three?
Yeah, absolutely. Going back to the example with the nodes where you had like one to introduce it, one to work it harder, and then one to reinforce it, and then one to introduce it in a novel way and just let the player go for it. With the portal example, they worked on nodes, so to say, with each chamber. And when they noticed a node that didn't work, they just took that portal room and they threw it out, and maybe they used it later. Or they would take the different nodes of the different chambers and they would flip them around to one where the players understood it more. So designing in a node-based way allows you to move things around so much easier instead of being concretely stuck to you go to this point, this point, this point, this point, all upon like a fixed path. Does that answer it?
That's right.
Nice. Glad to answer.
Shout out to my boy Creamy Bacon in the chat though. I miss you, buddy. You need to come for the next global game jam.
And they're
Yeah, I
A
think.
lot of slides here.
flying on by.
Yeah, that's a shit. I don't ever make as many slides.
Okay, we'll make you this clicker now.
I rely almost entirely on improv.
Yep. All right. Thank you very much.
Yeah, thank you, Etienne, and thank you to our wonderful viewing audience and our wonderful in-person audience here. You've been a great crowd today. You've done a lot. So yeah, this is our meetup. Thank you for watching if you watched. And thank you for presenting, Etienne. We'll be back next month with another exciting presentation on something. Who knows? We'll see you then.